So before today's video, where I'm going to be looking at the SS-11 board on the C9, I've got a couple of updates of things which I've got to do. So here's one of them. I need to fit this dash cam, yes I know, a dash cam, to the new car. The reason why I'm doing that is because I want to, well, basically just want to have a dash cam, because it could be quite good if I do sort of any driving or anything and want to video the footage. Not so much catching people pulling out on a roundabout, speeding up to a really ridiculous speed to try and catch them out, and then sounding the horn, which seems to be what the majority of the dash cam clips are. Mine is just, you know, I want to do a project. It's a project that I want to do. I want to fit the dash cam and see if I can integrate it quite nicely into the car. No hidden wire, well, sorry, hidden wires, no visible wires, that sort of thing. The next thing I want to have a look at is this, which is a Tassimo coffee maker from about 2015, and it has recently started to play up. And I think it's to do with this seal here. So I don't think that is sealing properly anymore. So what happens is it will make the coffee, or the drink, but then you get a load of water collecting around here. And it's because the seal between the spout and that isn't as good as it used to be. So I have a feeling that is the problem. The other small project I've completed, but I haven't actually bothered doing a video on it, is basically a way to reclaim water which I get from my dehumidifiers. So I've got one compressor style dehumidifier over here with a drain hose, and I have this desiccant based dehumidifier here, again with the drain hose coming out the back. The drain hoses meet at this rather shonky junction here, so they run under the carpet and behind the rear wheel of the Jag. They then come down this hose, and because I've set them higher up, they will actually drain into this Grundfos lift pump. The light is basically because the Grundfos lift pump has a 1 amp plug, so a 1 amp standard fused connection, so there's actually a 1 amp fuse in there. And on the other end it has a 240 volt outlet to sound an alarm. In this case I've actually wired it into a light. What I've also done is I've put another hose on the end of the Grundfos, and then that drains where it used to drain. The previous owner of the house actually installed this arrangement which goes all the way out to the back garden and terminates in a tap, which I've then basically run a hose from into the water butt. So water gets pumped up here from the pump through the hose and then ends up in the water butt. And if I want to, I can obviously isolate the connection, take this off and use it to provide normal water to the back garden should I so desire. At the moment it's just being used as a convenient drainage method for the condensate pump, which is there. Now I'll be honest, that Grundfos one's probably overkill, but it was one of the ones that when I was looking, it was one of the ones that had the furthest pumping height, so the highest pumping height and the longest distance. It was more distance than height, to be honest, that I was looking for. And the water butt is just behind that door, and you can see the hose there, which I need to find a more elegant way of tucking the hose in, maybe running it up over and behind the gutter, and then having it dip into the guttering where it drains at the moment. Anyway, that's not why we're here. We are here not for this, that's going to be something for another day, but we're actually here for the C9, which I periodically look at and then put away again when it doesn't work after me spending a few hours on it. So it's one of those sort of long-term things, to be honest with you. Anyway, what I'm going to do is get everything set up, get the soldering iron out, and we're going to start looking at the drive components that we need to replace. So if you remember from the last video, I actually replaced this board in the C9 itself with one which I'd purchased from a seller on eBay. And it turned out, even though the machine's still powered up, if you tried to put it into basically out of standby, every single light on the front panel would light up, which suggests that there is a problem with one of these 4 microcontrollers. So what I'm going to do instead is try and repair this board. Now, if you remember, the problem with this board, if I can get this off, is that we have a failed driver for one of the real motors. Now, I've had a look online and I haven't seen, certainly in stock faults that people have sort of highlighted, one of these actually failing before. So I'm actually wondering if it is indicative of or evidence of another issue. I managed to get this off last time I looked at it. How did I do it last time? Probably like that, to be honest with you. Anyway, that's inside now. And it was this one here which is burnt up. The rest of them look okay, although the plastic here seems to be quite badly melted around a couple of them, so I'm wondering if we've actually got a couple of these which have gone. This one definitely has, because it has burnt away slightly. Now, the annoying thing is you cannot access them from underneath because you've got this plate here. Obviously this plate will need to be replaced because that is there for some kind of probably RV shielding or RF shielding. RV shielding? I really need shielding from a recreational vehicle. Probably more for RF shielding than anything else. Not so much for the chip itself, but for the rest of the circuit board. So let's see if we can do anything about this. So I'm just going to rest this on here and just get these solder joints nice and warm. And then see if we can literally suck them up. Well, there's one. Although I don't think it's fully one yet. Ideally I need some of that sort of mesh type stuff that you just sort of run over the joints themselves, which sort of almost like soaks up the solder. Problem is I don't have any of that, so I'm going to have to use what I've got. Need to rest it for a while and hope that it starts to melt. Don't technically need to do all 4 because I should be able to just bend the panel up, so long as this one, and this one sorted out. I don't even think it's making a dent on this one. No, it isn't. It's just sort of... That's because the end tip is a bit contaminated. Let's try and clean it off a bit. I could potentially try a different tip that's got a instead of this very sort of thin end, try a tip that's actually got a broader tip on it. There we go. Let's see what it does for us. Actually try turning up the heat on the iron as well. Although to be honest with you, this is a cheap, very cheap iron. I'm not convinced the heat control does anything, although that suddenly has started melting quite a bit of that, so there is a possibility. Try some of these other ones again as well. Yeah, that's definitely hotter. You never want it too hot on the board itself though, because you could, and have, well actually I have, end up actually stripping the tracks off the board. Certainly the landing pads for the various components. There is probably a far better way of doing this. My method is flawed at best. So there's a big blob of solder there. If we're careful, we could try getting rid of that. Again, not too close to the board. Same on this side. Seems to be doing something. It's definitely clearing. Not quite sure how well it's clearing, but it's definitely clearing up a bit. There we go, and let's see if that has done anything positive. See, this is the thing, you don't want to prise too much on it because of just how the board is designed. I mean, ideally I'd want to clear this up around here because it looks like there is a locating pin. This just sits on this plate rather than trying to unsolder the whole assembly. So sort of unsolder all of that. Although doing that could be useful because it would give us full access to these components, which I don't know, I'd say this one and this one seem to be a faulty pair potentially, which is quite possibly why this is melted around them. So let's try that again. Just thought of something else I could do. If I hold it there, and then get this underneath, and do that. And that way you actually start to lift it off. So that's how already it's starting to come away. Do the same with this one. So onto there, and then keep the pressure on. There you go. Same over here. Onto there. Keep the pressure on there, and then your final one there, keep the pressure on, and there, and off. Ooh, crusty. Not sure if you can see that. Let me zoom it in. Oh, sorry. Let me zoom it in and focus. There. These joints here look almost burnt. Those are our drivers. But both look completely toasted, as if they've got way too hot. So let's drop the iron down. So we need to let this cool off a bit. So this will need to go down quite a bit. We'll need to let that cool off. And what we will do is we'll pop out both of those, because they look pretty toasted, to be honest with you. All the solder is destroyed around them as well. These ones don't look too hot either. I'm half tempted to take all four of them out, to be honest with you, because none of them actually look that great. Right. Okay, with this one, we don't want to be going too long on any of these joints. There's one. In fact, some of them don't even have any solder on them. It's almost like the solder's just literally burnt away. Well, melted actually. Probably be more case. Right, there we go. Leave those for a second. Let's go and fetch something to pull those out. So they're both out, and they both don't look particularly brilliant, to be honest with you. This is the plastic sort of shielding that goes around the side. That's the bit that was literally melted onto this one. This is the other one that didn't look too hot. and you can actually see on this one, sorry, I'm zoomed in, you can actually see on this one a bit of the circuit board has come away with it. It got that hot. So I'm just going to have a close look to see thankfully I don't think there's any track on it, it's more landing pads. And are the landing pads, I mean, it's completely ruined it. It's just charred beyond belief. So if I move over to the board itself, and if I bring this into view, you can see there where the board has become charred. You see, the thing is, let's have a look at the underside. So the underside looks okay. It has landing points, those landing points, although even there it's charred that as well. It has actually melted the board. You can actually feel the bump, sort of a dimple of where it's actually melted the board. That complicates things a bit, to be honest with you, as I'm not sure if the circuit for this is on the top side or if it's actually underneath. I hope it's underneath, and I hope it is one-sided. I just got an electric shock off or something, and this board has been out of the machine for ages. Ow. Wonder if it was from one of these capacitors. Probably is. Might be this fat one here, which is 16 volt at 2200 microfarads. Yeah, so I'm just not certain. I'm actually beginning to wonder if I should be continuing my work on the other board and determining what the problem is with the other board rather than continuing to troubleshoot this one. But the problem is, the other board's issue is arguably more complicated than this one, which I have already diagnosed. But the problem is, have those blown because something else further down the line is at fault? I just don't know. This is the problem, you see, when you get to this age, with machines like this which are this desirable, it's very difficult actually getting the spares, because ideally I'd like a complete spares machine that I could do some board swapping on. Yes, I know there's a bit of a basic way of doing things, but it does yield results, and it would allow me to at least focus on the board that's at fault. Yes, I know this board is at fault, but the problem we have now is the damage that's been done by those failing components. I'm just not sure what to do. I need to have a look at a circuit diagram, hopefully get a schematic of the board itself to see if there are indeed tracks at the top of the board as well as underneath the board. Otherwise I'm just going to be firing a parts cannon at the other board involving one of these microcontrollers, because I have a feeling, based on some similar faults which have been documented on PowerSite, that the issue is one of these microcontrollers, and then that opens up a whole new world of interesting developments. I think ultimately that's probably the way I'm going to go, given that this board has been damaged by that component failure, and given the location and the fact that these tracks are really close together, it's not a simple thing that I can repair with some fly leads like this. So yes, anyway, that's where we seem to be with this one at the moment. Anyway, if anybody's got any suggestions or comments or anything, please let me know. But as you can sort of tell, we do have some pretty baked components, to be honest with you. They do look a little bit sorry for themselves, as you can see there. And yes, sorry, I forgot to mention, those are the drive transistors for the reels. I mean, this whole section here is the drive circuitry for the various motors on the in the machine itself. It may also explain why when I press pause the capstan motor just starts to spin at full speed, and it's because of the damage that's been done in this particular section of the circuit. So yeah, it would seem the only remedy is board replacement. Anyway, I'm going to have a ponder, and I'm actually going to try repairing the other board. I think that's probably the way I'm going to go with this one. Anyway, if you found this video interesting, don't forget to hit the like button, don't forget to subscribe, and I'll see you again soon. Take care, and thanks for watching.